Hey everyone, welcome to another Open Cluster Management Community Meetings. Um, we've been talking about managing an entire fleet of Kubernetes clusters from a centralized location called the hub. So how can we ensure all those clusters that we manage are secure and stay compliant? So last week, we had the honor of having Yusal giving an introduction on the policy API and the framework, which will really help solve this difficult challenge. So this week, USAT will continue to take a deeper dive into the open cluster management policy and its related APIs. So without any further away, USAT, please take it away.
Thanks, Mike. So last session, 2 weeks ago, I presented the governance policy framework, and I showed you how the framework works, how you can create a policy on the hub and then propagate to manage cluster and then collect result back. So this week I'm going to talk about the configuration policy controller, which is part of Open Cluster Management project as well. This is one out-of-box policy engine that you will get if you are using Open Cluster Management project GRC framework. So now let me share. Right, so I think I'm sharing. So last week I go through this doc. So today I'm going to go a little bit deeper to talk about the configuration policy. You can find the link to the configuration policy controller repo from this governance policy framework repo as well. So there's a link to there. So if you click on this, this will help you find the repo of the configuration policy controller itself. So what is configuration policy controller? So by its name, basically configuration policy controller helps you to configure your cluster. By that I mean, so if you install it and a Kubernetes cluster, and you can create configuration policy CR what it does is you can define the object you want to create, you want to patch, or you want to delete. By simply defining a configuration policy CR, you can do basic CRUD operation on your Kubernetes cluster for any Kubernetes resources. So here's some fields that configuration policy CRD comes by. There's a severity field, which is optional. Basically, this allows you to specify the severity of this policy. Remediation action, so it supports two values, inform and enforce. So enforce is going to actually, if you specify enforce, this is actually going to correct any misconfiguration against the cluster. For example, you have if you use enforce, so and the Kubernetes resource you're going to create, patch, or delete, it doesn't match the desired state in your policy, defining your policy, configuration policy will try to remediate for you. If you specify it as informed, then it will not do anything, instead of just telling you this is not compliant and why. There's also a namespace selector, so the configuration policy does allows you to create to perform against multiple objects, perform against same object in multiple namespace. So you can just use this namespace set selector here to include and exclude namespace you want, and then the same object defined in the policy will be checked against all those namespace you selected. You can use wildcard here. For example, in this example, it will exclude all the namespace start with kube dash and then include default namespace. This is simply selecting only one namespace. You can use both selector or use either of them to achieve what you need. And then it's the object templates. So it's this field. So basically in this this is an array, so it allows you to define the actual object you want to you expect, or the desired state of the object you want to be. So this is an array, so you can specify multiple. That means you can create one configuration policy and specify multiple Kubernetes resources. This allows you to use one single policy to operate on multiple objects, or you can create multiple configuration policy, and each configuration policy operates on one resources. So the difference is by creating multiple configuration policy, you get finer grained violation details. But if you put them as one, this is treated as one single policy. So only all the desired state of your objects are met. This configuration policy will be only compliant when all the objects defined in the policy meet the desired state of what you define. So, and there's also a compliance type. So we support must have, must not have, and must only have, which I will go through in details. So this is part of the object template. So you need to define the behavior you want, must have, must not have, or must only have, and then the object itself. So you need to specify both for each single object. That's basically the syntax of the configuration policy, or the CRDs. So if you can run configuration policies in a standalone mode. So you can just create a cluster and then install this controller, and then create a configuration policy CR, and then it will the configuration policy controller will work, will do the job, and then report violations for you. To use it with the governance policy framework, you just embed entire configuration policy into the policy wrapper, and then the framework will use this policy CR to distribute the configuration policy to a managed cluster, and then collect results back. We have talked about this mechanism already in last session when we talk about the policy framework. So this is a high-level overview. So now I'm going to show you some actual use case. So all the examples I'm going to demo today, you can find it from here. So usage examples. So here I list the basic usage and the advanced usage for configuration policy. So the first usage is you can create a single Kubernetes resource in a single namespace. You can create a Kubernetes resource in a single namespace. So if you click on this link, this will give you a full example. So if we look at it, so this is a policy called policy role create. So this policy has a configuration policy embedded. So this is going to create a role, Kubernetes role called deployment role in default namespace. So this is an example to show you how you can create a policy or create a role in a single namespace. So we are defining the namespace inside the object definition directly. So this is how you create a resource in a single namespace. So I'm going to show you very quick here. So clean up. So here in the window on the right-hand side, I'm going to configure to point to the managed cluster called cluster 1. And then I'm going to watch all the rows in the default namespace. Currently, there's no row, right? And then I'm going to, in this window, I'm going to watch all the policy on the hub. And there's no policy. So now I'm going to create the policy. So I'm going to add the URL, then do kube apply. Oh, I think I already have the command here. So this is going to create, yeah, this one. This is going to create the row on manage cluster in default namespace for us. So let's do it. So I'm creating the policy placement binary placement rule here. So as you can see, the policy has been created in the default namespace and propagate to manage cluster 1. Now let's give it a few seconds for everything to work. Right now it is showing compliant, and you can see that the deployments row has been already created. So now let's go back and take a look at the policy. So what I'm using here is using MustOnlyHave. So MustOnlyHave means actually, I'm going to update this. This should be Musthave. So for Musthave, the different for Musthave. So when the object doesn't exist on the managed cluster, so there's really no difference between Musthave and must not have, since the object doesn't exist. It is just going to create it, and the created object is going to have exactly exactly same spec as you define in the policy. So for this example it is going to contain these rules. Now let's take a look at another example. So create same Kubernetes resource in multiple namespace. The main difference between single namespace and multiple namespace is this namespace selector. So in this example, we are, instead of specifying the namespace inside the row directly, you can use the namespace selector here. So basically, by using namespace selector, the configuration policy controller is going to create the same row in default and test namespace. So this is a difference. To save some time, I'm not going to demo this today. You can try it by yourself, as the example is here. So the next usage is merge patch. So say the object already exists on the managed cluster, and you want to patch it by doing a merge. This is where you use Musthave. So Musthave, when the object already exists and you use Musthave, this is going to so Musthave the basically means contains. So it is going to do merge patch. So in this particular example, this policy is going to ensure this deployment row contains these rules. If the object doesn't exist, it is going to create it. If the object already exists, then it is going to patch and inject these rules into the object. So let me do a quick demo here. So let me remove the previous policy. Now the policy has been removed. Let me apply it. I need to apply it on the hub. You probably noticed that when I remove the policy, it is not going to revert what it did on the managed cluster. This is how the configuration policy is designed to work. So it is not going to revert So that means it's not going to delete the deployment role. If you want to delete it, then you can create another policy to delete it, which I will show you later. So now I'm going to go ahead and create this merge patch example policy. I forgot to apply it on the hub. Let me do it again. Okay, now the policy is being created and enforced. Let's keep an eye on the compliance state. When it returns compliant, that means it has done its job. So let's take a look at this row on managed cluster. So if you look at here now, the policy has injected the additional rules into the original deployment role Kubernetes resource. So this is how merge patch work. So this is go back to previous page. This is how merge patch works. So it will make sure the specified object contains and is contained in the actual object. It is very similar for the resource in multiple namespace. You just use namespace selector instead of specifying the namespace directly in the object. I'm going to skip that as well. Now let's look at the replace patch. So in this example, now this is time for you to use MustOnlyHave. So if you do that, the configuration policy is going to replace whatever is defined, whatever exists in the existing object with the what you define here in the policy itself. So if I'm going to do that, the actual object on the managed cluster is going to be replaced. So that simply means this part is going to be removed. So now let's take a look. Let's try that. I'm going to delete the original policy first. Okay, it has been deleted. Let me apply it. The hub. So this is being created and propagate to the managed cluster. We need to wait for it to return the compliant state. It'll take a few seconds. Okay, now it's compliant. Now let's take a look at again the same object on the managed cluster. So as you can see here, the extra rules in the original row has been removed. This is for replace patch. Then it's the delete. So if you look at the policy here, so you use must not have. So to delete a single object, you just need to specify the name and namespace. That's how you delete a single object. If you want to delete multiple, then use the namespace selector. This is same. You don't have to specify anything else to delete a single object. You just tell the configuration policy controller the name and the namespace of the object. Now let's do that. Let me first remove the original policy, the previous policy. So now let me apply it. Policy is being created and enforced. And in a few seconds, this object will be removed. Um, so that's how you can. That's how you can use the configuration policy to do to create, patch, and delete. The other thing you can do is you can just do audit. So instead of let the configuration policy to actually perform anything, audit means it will just check and report you the result. So here is an example of how to audit a single resource in a single namespace. So the difference is you're using inform, right, remediation action instead of enforce. And then you use must-have, right, to make sure this object exists and contains. You can also use must-only-have and must-not-have. This all works, but this is only going to do audit because the remediation action is set to inform. Similar to previous example of how you operate against multiple namespace, you use the namespace selector here. So I'm not going to demo it to save some time. There's additional things you can audit here, which is audit a kind of resources. So in this example here, remediation action is informed. And then here, if you look at here, the object types here, in the object definition, we only specify the API version and kind. What this policy is going to do is, so based on the semantic here, must have, it means in default namespace, you must have pod. No matter what pod you have, you must have a pod, at least one pod. So we can, I'm going to demo, I'm going to apply this policy and show you how it works, okay? First, let me delete the original policy, previous policy. Here, I'm going to check if I have any pods in default namespace. Currently, I don't have any default namespace, any pods in default namespace. So if it works, then this policy is going to be non-compliant because in the policy, I want to check if the pod exists in default namespace, and by using must-have, it means I want the pod to exist in default namespace. So I'm going to apply this policy. So as you can see, the remediation action is set to inform. So we are doing audit here, and we are not going to change anything. So this is returning non-compliant here. So this is because we don't have any pods in the default namespace. If you look at the configuration policy, manage cluster, policy pod kind, yes. This is the configuration policy we're going to check. So it tells you no instance of the pods found as specified. That's why this is not compliant. And if you look at the policy, it contains same violation, non-compliant, no instance of pods found as specified. And you will also be able to find the same information in the hub by looking at the status field of the replicate policy on the hub. So now I'm going to edit this policy. So what I'm going to do here is I'm going to change the namespace. Currently, it's only checking the default namespace. Let me change it to open cluster management. First, we should have some pods running there. Management. Cluster manage. Oh, I have a typo here. Make sure there is pods running in open cluster management. There are some pods running on open cluster management. So now, as you can see, the policy becomes compliant. This is because we do have some pods running in the namespace we want to look at. So if you look at the policy here, you can see this is compliant because we do find these pods in the namespace open cluster management. That's why this policy now becomes compliant. So this is how you can use the policy to audit a kind of resources. So we're just checking the kind pod in certain namespace on managed cluster. There's one more thing you can do to audit is we can audit a kind of resources and with some filtering. So if you look at this example here, currently we add additional fields to the templates. So we are checking the kind pod and v1 and status phase running. So basically what it means is this policy is going to check in default namespace to see if the pods there is running or not. So this make a further step. This actually audited a further step. So previously we were only auditing if there are any pods, right? Now we are actually checking if there are any pods running by specifying additional fields in the template. I'm going to apply this policy. Let me copy it. Some cleanup. Let me remove the previous policy. And now I'm going to apply this. Oh. Now the policy is being created. Currently, we don't have any result yet. Let's give it a few seconds. Now it shows non-compliant. So the reason it's not compliant is because it's checking against the default namespace. But what I want to show is I'm going to edit this policy. What I'm going to do is I want to make to show you this filtering actually works. So I'm going to change the namespace here and to open cluster management. And I'm going to change because I already know all the pods are running in this namespace. I'm going to change this fields to something else. For example, failing. This is probably not an actual phase of the pod, but for demo purpose, I just want to make sure to show you this field filtering does work by specifying some value that it doesn't match the actual status on the managed cluster. So if I do that, this means I must have pods with phase running in open cluster management. But actually, we don't have this kind of pod. So this policy is going to be non-compliant. Let's save it. take some time, a few seconds to check to do the audit. In the meanwhile, we can take a look at the configuration policy on the managed cluster. You can see here, this is not compliant. If you look at the policy, you can see the history here. No instance of pods found as specified. This is because all the pods are not in a failing status; it's in running status. Okay, that's the basic usage. I'm going to pause here because I think we are out of time. Mike, can we continue or do we want to do another?
No, I think we should continue. I mean, we should take another slot 2 weeks later to continue talking about the integration because this is really great and awesome the way that you've been presenting these policy. I think if there's any quick questions, are there any quick questions that anyone have for Yusel? If not, then I'll conclude the meeting for this week. In 2 weeks later, Yusel is going to present again. Probably talking about the integration with other third-party policy-related softwares. Thank you so much, Yusel and everyone for attending. Take care.
Thank you.